This is Professor Pelton. This is Trigonometry, Chapter 3, Section 2, Law of Sines. This is Part 2 of 3. In Part 2 we're going to cover the ambiguous case. The ambiguous case is the case where you have the ass or ass backwards. This can be done with law of sines or cosines. We're going to focus on using law of sines to solve for lengths and angles. So typically in the ass case, you would not use that in geometry for the triangle congruencies because it does not make a unique triangle, which is why it's a little bit harder in trig to find sides and angles, because you have one of three cases. You either have one possible triangle, you don't have a triangle, or you have two possible triangles. What it comes down to is that last side in the ass case, is that last side when turned into its other side is only make one unique triangle. That third side might be too short, might not make a triangle, or that third side might be able to be turned to make two possible triangles. And there's a variety of ways you can do this with software and diagrams to show that. But those are the three outcomes when doing the law of sines or cosines in the as case. Okay. In the examples, the diagrams will not typically be given. They will be given in the lesson, so you can get an inkling as to what's going on, but normally you have to draw them yourselves, but they're not necessary. So the only ratio we know is the ratio of A. So that's sine of 75 degrees over 51 over, we want to solve for B now, so that's sine of angle B over 71. If I cross multiply, that gives me 51 times sine of angle B equals 71 times sine of 75. We have to solve for the angle this time, not a side, so we'll divide by 51. So I have sine of angle B equals 71 times sine of 75 degrees over 51. So to get the B by itself, I need to do an inverse function. So inverse sine of sine. And what you do to one side, you have to do to the other. So 71 times sine of 75 degrees, excuse me. Over 51. Okay. So that'll cancel, leave me with an angle B. Okay, and you'll put that in your calculator, and you'll get outside the domain, or some error like it in the calculator. And the reason being is, if you type in this value into the calculator, this value is greater than 1. Okay, just think about the possible values of sine have to be between 1 and negative 1. Since that's outside of it, the result is there is no possible triangle. Okay, so if you get an error on the calculator that says outside the domain, that means it's not possible. There's no angle there that's even possible to make that connect. Okay. Alright, so that's a case where there's no possible triangle. Let's try another one. Okay, so again, the only ratio we know is the A ratio. So that's the sine of 43 over length of 81. And the only other thing we know is B. So that means the sine of angle B over 62. So we cross multiply. 81 times sine of angle B equals 62 times sine of 43. And we'll divide by 81. So sine of angle B equals 62 times sine of 43. And we have to inverse over 81. You have to inverse sine both sides. Okay, so this time in the calculator it will work. So angle B equals 31.75 degrees. Okay? Here's the thing though. The calculator lies to you. The calculator says only the first answer, which is going to give you 31.75 degrees. But the reality is there's another 31.75 degrees in that quadrant because sine is positive in both the first and the second quadrant. There are an infinite number of answers if you go around the unit circle. However, we want the two answers are both less than 180. So you have this angle, which is your, we'll call that B1. Then we also have this answer here, which we'll call B2, and that's going to be your 180 minus 31.75, which in fact gives you a B2, which is 148.25 degrees. Okay, so that's 148.25. Okay. However, we were given an angle of 43 degrees. If you add 43 and 31.75 together, that leaves an angle C. However, if you add 43 to 48.25, that is more than 180. Since the 43 and this are more than 180, that means it would not be an angle C. So therefore, B2 is not possible in this case. So to get angle C, all I have to do now is 180 minus my B, 31.75, and the original angle of 43. So that means angle C1 is 105.25 degrees. Okay, so there's only one possible C and one possible B, because the second B adds up to more than 180 when you add A to it. Okay, so that means we just need side C now. So if that's 105.25, that is our ratio. So the sine of 105.25 degrees over side C equals the only ratio that we know, which is the sine of 43 over 81. So we'll do our cross multiplying. C times sine of 43 equals 81 times sine of 105.25. And divide by the sine of 43. Cancels. So C gives us approximately 114.6. Okay, so that solves that. We'll try the last one now. So in this case, we have only one possible triangle. All right, let's go with third case. Okay, so again, the only ratio we know is A. So that's the sine of 40 degrees over 54 equals the sine of angle B over 62. Okay, because the only other thing we have is a B, so we have to compare it to B. So do our cross multiplying, and we'll get 54 times sine of B equals 62 times sine of 40. And we'll divide by 54. So sine of angle B equals 62 times sine of 40 over 54. I have the inverse sine both sides. So inverse sine of sine equals inverse sine of 60. Oops, I almost put a 2. 62 times sine of 40 over 54. Okay, so this will give us our B1, which is approximately 47.6 degrees. But again, if you do the unit circle here, that's 47.6 there, and that's 47.6 there. So we have an angle B2, which is the one that goes to here. So you take your 180 minus the 47.6, and you'll get 132.4 degrees. Okay. All right, that means there must be C's now. So there must be a C1, and there must be a C2. Okay. Well, in both cases, this could happen because the only angle that was given was 40. So if I add 40 to 47.6, that's less than 180. And if I add 40 to 132.4, that's less than 180, which means there is an angle C left over. So if I add 40 to 47.6 and subtract 180, I get 92.4. And if I add 40 to 132.4, I get 172.4. Subtract that from 180, I'm left with 7.6. So that means I have two angle B's and two angle C's possible. And I showed that in the diagram here on the left, although I rounded the numbers off with my software, but very similar. Okay, but that also means there are two angle C's. Okay, because they're going to be the little c and the big C. So the only ratio we know is the A, so that's the sine of 40 degrees over 54. That's our A ratio, A side to angle side. We want to know side C now. That's sine of angle C over lowercase c, so we cross multiply. We get C times sine of 40 degrees equals 54 times sine of angle C. So divide by sine of 40. That'll cancel, so we're going to get a C1 and a C2. So the first time I do this, I need to put in that angle, and the second time I do it, I need to put in that angle. So I need to do this twice because I have two different C's. So the first time I do it, I get 83.9. And the second time I do it, I get 11.1, which makes sense because C1 is bigger than C2. Okay? All right, so we have two possible triangles in this case. All right, pause the video, try the student problems. Okay, student problem, same thing. You should get either no triangle, one triangle, or two triangles. All right, so the first one, the only ratio we know is A. So the sine of 50 degrees over 10 equals the sine of angle B over 20. So if I cross multiply, 10 times sine of angle B equals 20 times sine of angle 50, or 50 degrees rather. And divide by 10. So I get sine of angle B equals 2 times sine of 50. So set the inverse sine to both sides. So inverse sine of angle B equals inverse sine of 2 times sine of 50. So cancels, angle B is equal to, if we type that into your calculator, you'll get undefined or outside of the domain. Because in fact, 2 times sine of 50 is about 1.5, which is not within the sine range. Sine should have been within 1 and -1. So because that's undefined, there is no possible triangle, which means the side length is too short. So no matter how you change the angle, you can't get a possible triangle. Okay, there's no triangle there. Okay, let's try the second one. Okay, so again, the only ratio we know is A. So the sine of 57 degrees over 33. I'm going to compare that to B. So sine of angle B to 26. We'll cross multiply. 33 times sine of B was 26 times sine of 57. So divide by 33. So sine of angle B goes 26 times sine of 57 over 33. And we'll inverse sine. So inverse sine. Okay. So that's going to cancel, and we have a couple outcomes because we have angle B1 and angle B2. So if you type it in the calculator will give you 41.4 degrees, but there's another possible 41.4 degrees over here. So that's B1, 41.4 degrees, the first acute angle. So if we go from there to there, that gives you the other angle, which is 180 minus that, is 138.6 degrees. But here's the thing, we have to have an angle C. If there is an angle C, they must add up to 180. If I add 57 to 41.4, there's an angle C. If I add 57 to 138.6, that gives me 195.6 degrees. 195.6 degrees is more than 180. That means this one is not possible. Okay, so that means there is an angle C1, right? That's going to be the 180 minus the 41.4 degrees plus the 40. So that means angle C1 is 98.4 degrees. So there's only one angle C and one angle B, which means there's only one side C. That's the only thing that's left that we don't have. So we'll do a ratio now. So sine 57 degrees over 33 is the only ratio we know, which is the A ratio, side to angle. And we want to know C. So that's sine of, what do we got here? 98.4. And the C that we're looking for. So C times sine of 57 equals 33 times sine of 98.4. And we'll divide by the sine of 57. So C is approximately 38.9. Okay, so the first example was no triangle. Second example is one possible triangle only. Let's try the third example. Okay, again, the only ratio we know is A. So that's the sine of 35 degrees to 12 equals the sine of angle B to 16, since B is the only other thing we know. Cross multiply, 12 times sine of B equals 16 times sine of 35. And divide by 12. Sine of angle B equals 16 times sine of 35 over 12. So we set the inverse sine both sides. So inverse sine of sine, inverse sine of 16 times sine of 35 over 12. So therefore, angle B is approximately, you type that into your calculator, you will get about 50 degrees. We're going to round up this time just to make it easy. So if you do your unit circle, you get 50 in this quadrant and 50 in this quadrant for sine, which means that's B1 and B2. Take a second to think about it. It's coming from this axis. It has to be 130 degrees. So now there means there could be a C2 and a C1. So the original angle was 35. So if I add that to 50, that's 85. That means there's enough left over for an angle C, which is 95. And B2 is 130, so if I add the 35 from the original angle to it, that's 165, which leaves enough left over for a 15 degree. So that means there are 2 angle B's and 2 angle C's, which means there are 2 side C's. So again, we'll do the ratio of sine of 35 degrees over 12 equals the sine of angle C over 16. I'm sorry, not 16, C, because we're looking for C. So we'll cross multiply. C times sine of 35 equals 12 times sine of angle C. And we'll divide by the sine of 35. So C1 and C2. So in the first case, it's going to be 12 times sine over sine 35. In the second case, it's still going to be 12 times sine of something over sine of 35. The difference being is we have 2 angle C's. The first angle is 95, and the second one is 15, because we have 2 different triangles. As a result, for the first one, you're going to get about 20.8, and the second one, you're going to get about 5.4, which makes sense because the larger angle should give you the larger side, so on and so forth. And that is the end of part 2.